my name's Anella.
I'm Todd.
Okay, we're going to talk about robot geometry. So there are 4 main types of robot geometry. There is rectangular and cylindrical.
Spherical and jointed spherical.
Exactly. So the first one is rectangular and it's Cartesian. And Cartesian move with Cartesian coordinates, obviously, but... Oh, here you go.
So your example of your rectangular is
right here.
Right here. So rectangular is basically the same thing as it means. As if you can see right here, it moves in 3 axes, your X, Y, and Z, which is your left, right, up, and down. So the next one would be
cylindrical,
which is example right here.
And they move in 2 directions linearly, and then they rotate in 1. And then they use vertical linear motion known as your stroke, which is up and down, obviously. And then you also have your horizontal linear motion, which is your reach. I can't even feel like it's there, but it's okay. And then you have your rotational motion, which is your swing.
Okay, and it has a work envelope that over top would look like a C, if you can kind of imagine like a large C, and then it's up and down would give you your x-axis, I'm sorry, your z-axis, and from there it shows your height here. So the side view of it would almost be a rectangle as well. Okay, the third one that we have is spherical. So your spherical looks similar to this. It is a 3-axis system that goes left and right, which is your x-axis, your front to back, if you will, which is your y-axis, and your up and down, which is your z-axis. So it has a work envelope that over top almost looks like a C as well, but on the side it has more of a basketball with the top and bottom cut off of it. So similar to what you see here, it would be its work axis. And then finally we have the jointed spherical, which has up to 6 to 10 axes, depending on if it's on a slide or not. Yep. And its work axis almost looks like a basketball from the side, or from the front view would look like a basketball. Your top view would almost look like a heart, because behind it is where the safe place to stand would be and where your cords would hook into it at. So why the work envelopes are very important is because you need to know if you're going to move from gantry to gantry or from position to position, if your robot has the reach to be able to do it, and where to place your conveyors or your part set points.
It's also for safety reasons too, because you don't want to get in the way of it.
Right, and then the last thing we want to talk about is payload. So the payload of your robot is normally in the manual. And your payload is very important because it's how much that your robot can lift and move at the speed safely without having a wobble in the end or an up and down. And there's a calculation on that of if you take 100 pounds, you take 25% off of that, or take 75% of the 100 pounds, which the reason we used 100 is because it'd be 75 pounds. And that also includes the weight of your gripper or your material handler on the end. So when your robot is moving, it doesn't overshoot its target or have to approach slower, so it doesn't get a wobble left and right or up and down, depending on what your movements may be. So thank you for listening, and we appreciate your watching.